Hi, we're going to talk about solving inequalities now. That's lesson 1.5. We've already talked about solving equations or equalities that produced at the most one solution, or we could have had no solution. We've talked about solving absolute value equations, and we had no solution, one solution, or two solutions because we could measure distance both going to the left and to the right on a number line. And now we're going to solve inequalities, which is going to give us a whole range of solutions. So we have to know how to correctly write a solution to an inequality. And as we go through this, I want you to just kind of think about why would it be so important in this day and age in our world? Why would it be really important for us to correctly write a solution? So think through that. That's going to be your discussion question. So let's review how to graph an inequality because they have a range of values. It's not just a single number. We have the first example here is, I guess I never set my pen. The first example here is x is greater than -1. Greater than doesn't have the equality part to it, so we're going to use an open circle. And greater than says it's got to go to the right. And that's how we would graph x is greater than -1. If we wanted to graph x is less than or equal to 4, we would put in a closed-in circle, solid circle, over 4, and then that points to the left, so we're going to draw it off to the left like that. Another example we're going to use throughout this video is x is greater than -1, and at the same time it's less than or equal to 4. Notice how x is between. Okay? That means our solutions are going to be between those two endpoints. So graph those endpoints and then connect a line. So I have -1, and that's an open because of this inequality symbol being less than, without the equal part. And then I have the 4, and that has you learned how to graph this in Algebra 1. I'm just kind of reviewing it. Okay? And you connect them with a line. All your solutions, the line has to be between the two endpoints. This is x is less than -1 or x is greater than 4. So I would have a -1, an open circle, and then a line going off to the left. And then I would have, again, this one I used just a greater than, not greater than or equal to. So that would be open circle and then off to the right. So if you're not sure how to graph it, rewatch that section. Okay. Now, when we use set notation, it's a method of writing the solution. In math is a language, so it's really important that we write solutions that globally people can understand. So set notation uses braces like this and a vertical bar like that. Okay, so, and it's red. Here's an example that I just made up an example. I'm going to do it for the ones below, but this is brace x, vertical bar, x is greater than 2. This would have been the solution when we solved. It's red, all x's. That's what this piece means, all x's. This vertical bar is translated such that. The vertical bar means such that or so that. And then we have this expression, which is our solution when we solved, and we just read it like we have since pre-algebra. X is greater than 2. Okay? So if I wanted to take this solution, all right, and write it in set notation, I'm going to do brace all x's, so there's an x, vertical bar such that x is greater than -1. That's set notation. The second example, set notation, I'm going to use abbreviation set note. Okay? We have all x's such that x is less than or equal to 4. So you're taking your solution, you're putting two braces on it, and an x in a vertical bar, or a variable in a vertical bar. Okay? Now, this one, we graphed it before. Here's the graph again. We're going to write like this. All x's such that -1 is less than x, which is less than or equal to 4. Again, look at where your x is. It's between your endpoints. Our solution, our line is between our endpoints. Okay? And then finally, this one. Hopefully you're noticing you just take your solution and add some elements to it. All x's such that x is less than -1 or x is greater than 4. Okay? That's set notation. Set. Okay? Now, the second method is called interval notation, and while it seems more difficult in the beginning, it's actually much easier to write. Okay? This is a notation. Instead of using the braces, it uses parentheses and brackets. Okay? One thing that students get confused about is that they kind of think of it as an ordered pair. It is not an ordered pair, so you want to make sure you understand that. Here's when you use a parenthesis. Use a parenthesis when you have the greater than symbol without the equal, or the less than symbol without the equal. What this means is that the endpoint is not included. Okay? You're also going to use parentheses anytime you have an infinity, either in the negative direction or the positive direction. Negative infinity says this goes to the left forever and ever. Positive infinity says that the solution goes to the right forever and ever. Okay? Now, brackets, brackets are used when you have the less than equal to symbol or the greater than equal to symbol. And these are the times when your endpoint is actually included in the solution. When you use interval notation, it's always important that you realize that the smallest value goes on the left side of the interval, okay, regardless of what the graph is looking like. So let's just kind of go through what we would use in each one of these cases. So if you had a positive infinity, you're going to use a parenthesis because infinities always use a parenthesis. This one is going to be a right parenthesis. With a greater than or equal to, you're going to use a bracket. Okay. With a less than, you're going to use a parenthesis. With a greater than, you're going to use a parenthesis. With an infinity, a negative infinity, you're going to use a parenthesis. And with a less than equal, you're going to use a bracket. All right? So let's try these on our examples. This says, again, x is greater than negative 1. What's the smallest value that this can be? That's going to go on the left. It's going to be negative 1. Does it include negative 1? Nope, we can get really close and not touch it. All right, what's the largest value? If it goes off to the right, that just keeps going and going and going. We say that goes off in the positive infinity direction. X is less than or equal to 4. What is the smallest value that we're going to have here? This is going off to the left forever and ever and ever. See how it's going off to the left? Okay, it just keeps going. So we're going to use infinity in the negative direction. What's the largest value it's going to be? 4. Does it include that endpoint? Yes. So we're going to use a bracket. Let's use it on a closed interval. This says my smallest number is negative 1. Does it include that negative 1? No, it can get really close, but it can't include it because that's an open dot. And then my biggest number in my interval is 4. Does it include that interval? Yes. So I'm going to use a bracket. The last example is x is less than negative 1 or x is greater than 4. And or, in interval notation, is going to use a U for a union. So look at this piece first here. What's the smallest value? Well, it's going to infinity in the negative direction. So we have to use a parenthesis. Its highest value is negative 1. It doesn't include it because that's an open dot. That's an exclusive symbol. So we're going to use a parenthesis. And then we're going to use a union. The union represents this blank spot right here. It says we're going to skip a whole bunch and then we're going to pick up some more. Right? I have, in this case, my 4 isn't open, so I have parenthesis. If that had been with an equal sign, we would have picked up a bracket. So that would be 4 to positive infinity. Okay? All right, so here's the discussion post question. Why is it important to write a solution in correct form? So think about the global world, think about technology. Why do you think this is going to be so important? All right, watch part 2 of the video and remember about Quizlet. Thanks.